Oh my gosh. Like, it's like, yeah, you have to run like that. Like, it's like, where did they hire this guy? Where did they find him? Okay, here we go. Everything you do today will be important for you to move forward with. Could you imagine solving 2x plus 3 is equal to 11? Could you imagine being in algebra class and trying to complete second semester of algebra but not knowing how to solve that? That's what it will be like for you if you can't do what we do today. That's how fundamental what we are learning today is. Yes. Unit circle, circle of life, let it flow. Here we go. We start with 0 degrees, 360 degrees. That means that this is what? 180. This is down here. I'm going to take that 90. I'm going to divide it up into important pieces. I'm going to divide it in half to get 45. Divide it into thirds to get 30. I'm going to double that 30 to get 60. From the rest of that, I'll produce all the other angles. I go 30 degrees past 90 to get to. I go 45 degrees past 90 to get to. I go 60 degrees past 90 to get to. Everybody clear with the markings so far? Any issues? 30 degrees past 180. Stop it. Hiccups are not allowed. 45 degrees past 180. $60 degrees past 180 is 240. 30 degrees past 270 is 300. 45 degrees past 270 is 315. And 60 degrees past that is 330 degrees, all the way around 360. Any questions how we got those? Okay, now that's the first part of the unit circle. That's the easiest part. Let's now do the more challenging part, which is convert all of these to radians. We're going to teach you to do it quickly, and you're going to do it excellent. And you're going to do it so well that I will give you a quiz on it next week with no calculator, and it'll be timed, and you'll do excellent. Are you ready? Like, if I say it, I got to own the challenge. Like, I got to be able to prepare you. I can do it. I believe in myself, and I believe in you. 180 is the same as? Pi. 0 is the same as 0. 360 is the same as 2 pi. Great. From that, let's generate all the others. All you have to remember is pi is 180. That's all you have to remember. Can we live with that? 90. How does 90 compare to 180? Half. So it's therefore it's pi over 2. How does 60 compare to 180? 1/3. So it's pi over. Rach, right here. How does 30 compare to 180? It's 1/6. So it's pi over 6. $180 is like 1 whole pi. Okay? You've got 45. How many 45s fit in 180? 1, 2, 3, 4, right? There's 4 of these slices that fit within 180. So 45 is pi over 4. Folks, all we're doing is this. So if you take 60 times pi over 180, we are just trying to think of a quick way to go through that. 60 goes into 180 3 times. We get the conversion pi over 3. I'm going to show you a quick way of doing the conversion of what you did yesterday. This is the best way I figured out how to teach it, and I feel like most students are fully capable of doing it, and you're good to go. All you got to do is memorize these 5 right here. 0, pi over 6, pi over 4, pi over 3, pi over 2. You think you can do that? And I know you can, because I've seen you memorize 486 things for your handing test, and you no problem doing that. So you can memorize 5 things in this class and put them to use. Are you ready? Of course you are. 120. Which of these divides evenly into 120? 60 is the biggest one. 30 does as well, but 60 is the biggest one. How many 60s go into 120? So it's 2 of these. It's 2 pi over 3. Which one of these divides evenly into 135? 45. How many times does 45 fit into 135? 3 times, so it's 3 pi over 4. What divides evenly into 150? 30. How many times? 30 goes into 155 times, so it's 5 pi over 6. 210. What divides evenly into 210? 30. How many times? 7. 7 pi over 6. 225. Which one? 45. How many times? 1, 2, 3, 4, 5. You guys, I never do 225 divided by 45 in my head. I never do that. I don't know what that is. I count. 1, 2, 3, 4, 5. It's 5 slices of pizza. That's how I do it. 240. Which one? 60. How many times? So it's 4 pi over 3. 270. Which one? 90. How many times? 3 pi over 2. 300. Which one? 60. How many times? 5. 5 pi over 3. 315. 45. I don't know what 315 divided by 45 is. I count. 1, 2, 3, 4, 5, 6, 7. What that velociraptor thing? It kind of came out of nowhere, didn't it? It was a little aggressive. Yeah. Yep. 330. 30 goes in how many times? 11. 11 pi over 6. Lots of ways to think of it. That's one way. That's the way I like to think about it. You need a scratch sheet of paper, a pencil, and a group of 2 or 3. Go. Okay. Thank you for that fun activity. For those of you on YouTube, we converted between degrees and radians really quickly. We used these chief values. They came up with all the rest. They had a lot of fun. Some trash talking back and forth. So here we are. We go back to the circle of life. Here it is. You have the second part of the unit circle, which is the conversion from degrees into radians. You need the third part, and this is the most challenging part, okay? What we just did was not the challenging part. This is the challenging part. What is this coordinate right here? 1, 0. What's this coordinate? And we determined all those around there yesterday, right? Like on the axes. But the question is, what about this one? What about this one? What about this one? If you notice, what's interesting is that they all have, angles of 30, 45, and 60 in common as you kind of head around the circle, don't they? And so as we try to find these locations, those locations are really, really important as we move forward in trigonometry. And you need to be able to come up with them. I would like to say that you'll just learn them once and never use them. That's completely false. You use them in calculus, use them in calculus 2. You use them in differential equations. You use them all the time, and especially you're going to continue to use them in trigonometry. So I'm going to ask you for the rest of the year, I'll say, what is the sine of 60? And I want you to say, it's the root of 3 over 2. I'll say, what's the tangent of 60? And I want you to say the root of 3. I want to say, what is the cosecant of 90? And I want you to be able to say 1. Okay, I want you to be able to come up with those things. That's not going to happen unless we get this next piece figured out. This is critical. We are going to figure out those locations. In order to do so, we have to do some geometry. Do you remember special right triangles in geometry? Samantha is on the ball. 30, 60, 90 and 45, 45, 90. We're going to start with the 30, 60, 90. I used to think that everybody remembered this stuff, and I figured out they don't. And then I used to spend a whole day reviewing 30, 60, 90, and that was a waste of time because people then remembered it for a day, but they continued to forget it. So I'm going to spend 5 minutes on it, and if you can't get it, you got to come and see me. That's all there is to it. Are you ready? 30, 60, 90, where does it come from? It is half of a 60, 60, 60. That's where it comes from. What's special about a 60, 60, 60? All of the sides are the same and all the angles are the same, right? So if I had a 60, 60, 60, and this side was 14, what would be the length of this side of the 60, 60, 60? 14. What would be the length of this side? 14. But the fact is we take this and we cut it in half. So therefore, what does this side over here become? 7. So everybody convinced that that is half of the hypotenuse. Do you remember what you do to get this long leg here? Yes. Yes. We can do the Pythagorean theorem. I'll do it once. Fair enough? We'll do it once. Okay? Just because you don't need to continue to do it. There's a much shorter way. If you, say, had this shape right here, and you said that this was 2 and this was 4, you're going to find that side. You'd say 2 squared plus b squared is equal to 4 squared, right? You got 4 plus b squared is equal to 16. So b squared is equal to 12. Square root both sides. What is the perfect square you take out? So you get 2 roots of 3, right? So notice it's just that number times the root of 3. Every time, it always works out that you just multiply by the root of 3. Last hour we did a proof to show that that was the case. Riley asked to see the proof. Yep, everybody yelled at her. So we did the proof. So this is going to be 7 roots of 3. Hey, that's amazing. Well, I wonder if I change it. Like, what if this was 10? Then what would this be? 5. And what would this be? Hey, look, isn't that easy to do now? Like, it's really a very quick and easy concept, isn't it? Like, what if I give you this one? What if I call this one? We're gonna call this one 9. And this is 18, and this is 9 roots of 3. See, I mean, you just go back and forth between the legs very quickly. That's the beauty of the 30, 60, 90. We good? Okay, what about the 45s? God, Sam, you are on fire today. All right, so Sam's absolutely right. We could do a proof here as well if we wanted to. Here you get, let's say that this side is 6. I mean that this side is 6, and Sam says that this side is 6 times the root of 2. So you don't multiply by the root of 3, you multiply by the root of 2, and there you have it. Yeah. So suppose that this was a length of 0.4. Then this would have a length of 0.4, and this would be 0.4 roots of 2. Easy, right? What if I change it? What if I say this is 8? Well, in order to go from this side to this side, you multiply by the root of 2. So to go from that side to that side, you divide by the root of 2. So you'd have 8 divided by the root of 2. Well, multiply top and bottom by the root of 2, and you get 8 roots of 2 over 2, which is 4 roots of 2. Nice thought, but incorrect. So 4 roots of 2 right there, okay? So, you know, sometimes you have to divide by the root of 2 then. This one, a 60, 30, 90. And it's just like the 30, 60, 90. I just add another one there so we can recall and hopefully master this idea. Suppose that this length was 30. What is this length here? 15. And what is this length? We all good to go with our little 5-minute geometry special triangle review? Good. Now let's find those terminal points that we talked about. Given a t value or a theta value of pi over 4, what we want to do is we want to come up with the terminal point at that location. First of all, I have to figure out what angle is pi over 4. What degree measure? 45. draw a 45-degree angle. I drop a height or an altitude from that point to the x-axis. Always go to the x-axis. Got it? Who can tell me what this coordinate is? What's this coordinate? Anybody know what the length of the hypotenuse is of this triangle? Why? It's the radius. The hypotenuse is the same thing as the radius, right? And the radius is always 1 in the unit circle. So every time we do this, you always know that the radius is 1, 100% of the time. Shoot, it's a 45, 45, 90, isn't it? So if I'm going from the hypotenuse to this side, do I multiply by the root of 2 or divide by the root of 2? So I go 1 over the root of 2. Can I leave the root of 2 in the denominator? So I have to multiply by the root of 2. I get root of 2 over 2. If the base is the root of 2 over 2, what's the height? Because it's a 45, 45, 90, right? We got the root of 2 over 2 here as well. So the question is, what is this location? That's what we're trying to answer, is that point. And its location ends up being the root of 2 over 2, root of 2 over 2. That's the location, the x value and the y value. What do you think? We should try another one. 4 pi over 3. How many degrees? 240, because divide by 3, you get 60. Multiplied by 4, you get 240. 240 degrees. Which quadrant does that place me in? Third quadrant. How many degrees past 180 is it? 60. So as you draw it, you might draw something like that. 60 degrees past 180, draw a height or an altitude to the x-axis. That will be the drawing that gives us our terminal point that we need to locate. What kind of special triangle do we have? 30, 60, 90. What is the length of the hypotenuse? 1, because you're in the unit circle. It's always 1. Now what? If you know the hypotenuse is 1, what's going to be the length of the shortest side? 1/2. How do I go from the shortest side to the longer side then? Multiply by the root of 3. So if you multiply by the root of 3, you get root of 3 over 2. Anybody want to guess what my location here is? Yeah, good. They're both negative because you're in the third quadrant. So your location is negative 1/2 and negative root of 3 over 2. Good work. You guys are doing well. Oh no, the next one's negative. No soul, right? Negative, that's no problem for us. We just go the other way. 5 pi over 6, how many degrees is that? 150. So how many degrees from 180 does that bring me? 30 degrees. That's my location for negative 150 degrees. Good work. What's the length of the radius? Hypotenuse. 1. Shorter side? 1/2. Longer side? Root of 3 over 2. Hey, we've already done that, haven't we? So what's the location of that terminal point right there? Negative root of 3 over 2, negative 1/2. Similar to the last one, but the x and y values are switched. Would you like a super easy one? Negative pi over 2. That's negative 90. Place you right here, right? Everybody wants to draw a triangle because you're used to drawing triangles. Remember, our goal is to just figure out the terminal point where we end. Do you know that location? What's that location? We don't need to draw a triangle. You know that spot. Done. Is that nice? Sweet. I'll end with this. You came up with these values. 0, 1/2, root of 2 over 2, root of 3 over 2, and 1. Those are all the values you came up with. Did you notice that the root of 2 over 2, it got paired with itself? Did you notice that these two always got paired with each other? Did you notice that these two always got paired with each other? And that's how it will always be in the unit circle. They will always pair together like that. Some will be positive, some will be negative, but these will always pair together. You might wonder, why did I write them in that order? Because these are the values. These are the decimal values, 0, 0.5, 0.7071, 0.866, and 1. They go in increasing value that way. And those values are very important to us. You'll see why as we move forward. I think you guys got it. I think you're in good shape. See? You came back to school, you're like, I wonder if Gent is going to do anything the first 2 days. And you're like, well, of course we are. We couldn't lose 2 days of learning. And look it, we've already learned how to convert degrees to radians. We've already learned about terminal points. Have you learned something new over the past couple days? And you will learn something new every single day you come to this class for the rest of the year, because that's what trigonometry is. No more of this synthetic division stuff. No more of this solve for x. No more quadratic formula. It is all trigonometry, brand new, every day. Here's your assignment.